Video, we're going to be deriving the equation of motion for a 1 degree of freedom mass spring damper system using the Lagrangian model. So the Lagrangian formula is simply L equals to T minus V, where T is kinetic energy and V is potential energy. Now our kinetic energy in this system will be given by the mass, which is here. That will be half mv squared. Normally you write mv squared, but in this case for easy representation, we're going to have, since we know distance is x, differentiation of distance is velocity, which is dx over dt. In this case we denote it as x dot, and acceleration x dot dot, and so much more. So in this case we're going to write this as x dot square. Now the next is the potential energy. Potential energy is provided by the spring, so it will be half k. Now spring resists displacement, so in that case to be x square. And lastly, the Rayleigh's function for the resistive force, which is the damper, which will be half c. Now damper resists velocity, so dot square. Now let's write out our Lagrangian. Just be simply t minus v, which will be half m x dot square minus half k x square. Now we're going to use the Euler-Lagrangian formula and write it out, which is d over dt of the partial differentiation of the Lagrangian with respect to x dot minus partial differentiation of the Lagrangian with respect to x plus the Rayleigh's function partial differentiation of it with respect to x dot, all equals to 0. We'll take this first. So now in the Lagrangian, you look at which formula has the x dot. In this case is this. So if we differentiate this with respect to x dot, we're going to get mx dot. Next, if we differentiate this with respect to time, you're going to get mx dot dot. We're just differentiating this, which was simply this. We're differentiating it with respect to time, which now gives us this. So enough of that. Now next we're going to do this function, which is differentiation of the Lagrangian with respect to x. Simply look at the formula and see who has x. In this case is the spring. So we're going to differentiate this with respect to x. We're going to get minus kx. And lastly, we're going to do this part, which is the resistive force with respect to x dot. We'll simply have cx dot. Now it's simply just to write out the full formula, which will be this first, which will be mx dot dot, and this is minus, so this will become plus kx plus cx dot equals to 0. So therefore, this is our final equation of motion for the system. Now you can also go and check out my website. There I have solved out 1 degree of freedom, as well as 2 degree of freedom and 3 degree of freedom. So you can go and check out my website to see how this is solved. Thank you for listening, and don't forget to leave your comments in the comment section, as well as don't forget to subscribe.